This activity aims to introduce the use of hand auger for obtaining disturbed soil samples and the standard method of storage of soil for future laboratory use. The students shall be able to understand the standard procedure in soil sampling and handling, perform the soil profiling as observed from the results of the experiment. Discussion. The simplest method of soil investigation and sampling is through the use of auger borings. This method is applicable for retrieving disturbed soil samples that are to be tested in the laboratory to further determine its engineering properties. However, it is important to be reminded that improper handling and storage of the sample can compromise the integrity of the soil investigation conducted. A standardized labeling of the sample is beneficial as the soil sample, INGERAL, is handled by different personnel in the field investigation and in the laboratory. It is important that all pertinent data observed on the field are to be written down in the sample label in addition to the primary record book of the site engineer. The data in the sample label will direct the laboratory personnel in finalizing the borehole log, which is to be counter-checked by the site engineer's primary record book. Resources: 1. Soil auger. 2. Spade or shovel. 3. Moisture tight containers. 4. Pans. Clear the area of grass and vegetation where the sample is to be obtained. Create an alignment of 3 boreholes that are about 3.0 meters away from each other. With the use of soil auger, the soil is bored until desired depth is reached. After a half-meter advancement, withdraw the auger to the hole and remove the soil for examination and testing. Record the depth and the observations on the soil sample retrieved. Seal the soil sample in a moisture-tight container and label appropriately. Extract again the soil in the succeeding borehole advancement until a depth of 2 to 3 meters is reached. Repeat procedures 1 to 4. For borehole number 2, draw the stratigraphy of the site to determine the geometry of the soil layers. Here are our observations of each soil samples from borehole 1, 2, and 3. For borehole 1, from 0 to 0.5 m, the soil is slightly wet. Then for 0.5 m to 1, wet rocky soil. At 1 to 1.5 m, the soil is saturated with visible seepage, and at 1.5 m to 2 m, the soil is saturated with visible groundwater. For borehole 2 at 0 to 0.5 m, the soil is slightly moist and cloddy. At 0.5 m to 1, the soil is cloddy with few particles. At 1 to 1.5 m, the soil is already wet. At 1.5 m to 2 m, the soil is highly moist to near saturated. For borehole 3 at the depth of 0 to 5 m, the soil is slightly moist. At 5 m to 1, the soil is moist. At 1 to 1.5, the soil is wet with visible seepage, and at 1.5 m to 2 m, the soil is near saturated with visible groundwater. The borehole location map. This is the illustration of stratigraphy of each borehole from different depths. Based on observations, soil moisture increased with depth in all boreholes. Borehole 1 had the highest saturation with visible groundwater. Borehole 3 showed minor seepage, and Borehole 2 was least wet saturated with no visible water. Rock fragments were observed in all boreholes, indicating the presence of coarse materials within the subsurface profile. Results are based on disturbed, visual, manual observations from manual drilling.